Okay, so now moving on to the next question, 10th. Here we have been given a plot that shows the variation of negative of natural log Kp versus temperature for the two reactions. First is the metal is getting converted to its oxide, and second carbon is getting converted to its oxide. Here it should be gases, so that's a mistake. Now this diagram reminds us of the Ellingham diagram in the metallurgy. So in the Ellingham diagram, the parameter on the left side is actually delta G naught versus temperature. Now we know that delta G can be written as delta G naught plus RT natural log Kp. So at equilibrium, delta G becomes 0, and we have the equation delta G naught is equal to negative RT natural log Kp. And if you take this value negative of log Kp to be x, then you can write delta G naught is equal to RT into x. So you can see that delta G naught and x are directly proportional. So instead of writing delta G naught here, if you're writing x, that is negative of log Kp, it is similar criteria. Okay, so now we have two reactions, and we'll consider a point that is below 1200 temperature. So let it be point A. So at point A, temperature is fixed, system will be in equilibrium. So we'll write the two reactions. So at point A, the first reaction, carbon gives you carbon monoxide gas, and for this, now they've given value starting from 0 going up in a positive manner. So let us say at point A, this is somewhere around 20. Okay, we'll just take a rough idea. So delta G naught value here, because it is directly proportional to x, so we will take it to be around plus 20. And since this metal graph is above metal to metal oxide, so let us say it is plus 30. So metal to metal oxide solid, delta G naught is plus 30. Okay, now if you revert this second reaction, metal oxide to metal, so MO to metal, delta G naught will become minus 30, and then you add the first and third step. So you get carbon plus metal oxide gives you metal plus carbon oxide, and delta G naught for the reaction is minus 10. So it's a spontaneous reaction. Okay, so we can say that whenever we are within this range 0 to 1200 Kelvin, the carbon can reduce this metal oxide because the delta G naught for the reaction is coming out to be negative. Now take another example at any point above 1200 Kelvin, let it be B. So at point B, this carbon gives you carbon monoxide gas. So now this value is almost fixed. So let's say it is again plus 20, and metal to metal oxide solid, delta G naught. Here this value is even lower. So let us say this is plus 10. Okay. Now if you reverse this to make metal oxide reduced into metal, then this will become minus 10, and then you add first and third. Carbon plus metal oxide gives you metal plus carbon oxide, carbon monoxide, and you get delta G naught for the reaction as plus 10, that is non-spontaneous. So the carbon should be able to reduce the metal oxide whenever the temperature is below 1200 Kelvin. So this reaction, metal oxide solid plus carbon solid gives you metal solid plus carbon monoxide gas, is spontaneous at temperature less than 1200 Kelvin. So second option should be the correct option. Now moving on to the next question, 11th. Incorrect statement regarding the heavy water. Now we all know first option like aluminum carbide. Aluminum carbide, whenever reacts with water, it produces methane gas because Al4C3, if you break down into ions, it will become aluminum 3 positive and carbon 4 negative. So carbon 4 negative is going to attach with 4 positive charges. That may be 4H positive or it may be 4D positive. So the reaction with heavy water will be 12D2O plus Al4C3 gives you 4 aluminum deuteroxide and 3 CD4. Okay, so this is correct, first option. I mean, not the incorrect one. I mean, this reaction does take place. Second, it is the used as a coolant in nuclear reactors. It is completely wrong because heavy water is not used as a coolant, but it is used as neutron moderator to slow down the fast moving neutrons so they can be captured by the uranium 235 and not the uranium 238. Okay, so its function is not as a coolant, its function is as a neutron moderator. So the incorrect statement should be 2. So answer should be 2 here. Third option, reacts with CaC2 to produce. Yes, calcium carbide when reacts with water produce acetylene C2H2. So with heavy water it will produce C2D2. Okay, and similarly D2O plus SO3 will give you D2SO4. Okay, so the incorrect statement here is second option.